planet Earth, an enormous world created by monumental forces of nature. And it's the only place we know of in the universe that has fostered the miracle of life. Ever since the dawn of humanity, we've been on a quest to understand how all of this came to be. Nature is about to embark on the most ambitious project we have ever undertaken. In the next 5 programs, we explore the unfolding story of volcanoes and tides, earthquakes and climates that sculpt the world we know today. We begin with a journey back in time to the very birth of the planet. Here among the lava flows of Volcanoes National Park, Hawaii, we catch a glimpse of that once raw, new world.
Listen, and I will tell you a story of how the world came into being. There are many such stories, but this is a tale from the great Icelandic sagas. In the beginning was a land of ice and freezing fog, from whence came coldness and all things grim. And then there was a land of fire. Bright and hot, flaming and burning. Sparks from the land of fire fell onto the land of the cold and melted the ice. Between the cold of ice and the heat of fire, a new world was created. A world where the forces of nature were perfectly balanced. This is the story of that world, a living, vibrant world, a planet called Earth. The beginning of humanity. And with the first glimmer of human consciousness came the need to explain the forces that shaped the world, a world that was seen with awe and wonder. "30,000 years ago, our ancestors carved this figure of their vision of the earth, a mother goddess. Deep within the womb of their mother, in the darkness of her caves, they forged a magical relationship with the earth, and she gave them their daily bread. We have, of course, made progress since then. Our technology allows us to take our first faltering steps away from our mother. A few of us, like the gods themselves, have now gazed down on the earth, yet our reaction is still that of wonder. For many astronauts, their view of the planet below was a glimpse of divinity. Planet Earth is a wonderful place. Its face etched with canyons and mountains, rivers and lakes. It's carved by forces of such monumental power, they're beyond measure. Yet, despite such overwhelming power, there is everywhere a thin, delicate veneer of life, its patterns shaped by the same forces that shape the planet. As fragile as it is, life has become one of the greatest forces to shape the Earth. But why is planet Earth covered in such a dazzling variety of life? What makes this place so special? And the biggest question of all, how did it all begin? Our journey of discovery starts not on the planet itself, but deep in space. In this distant nebula, stars are being created from gas and dust. But we're not just seeing across vast distances, we're seeing through time itself. When we gaze at the night sky, we see stars and galaxies as they were in the past. Light from this galaxy has taken 78 million years to reach us. If someone was watching us from far enough away, they would see our past, our solar system coming into being, the beginning of our story. It's 4.5 billion years ago, in a vast cloud of dust and gas. Concentrated at the center, it's getting more dense all the time. As it collapses in on itself, it grows hotter, so hot it triggers a massive nuclear chain reaction. This huge ball of burning gas swallowed most of the dust cloud, but enough was left over to form tiny grains, which fused together to form rocks, which fused together to form planets, our solar system. Close to the sun, the heat is intense. With a surface hot enough to melt lead, Mercury is a cauldron. Farther away from the sun, the temperature drops well below zero. Comets of ice make their lonely journeys through the cold of space. 200 million miles from the sun, beyond the orbit of Mars, drift rock fragments that were never destined to build a planet. They remained as asteroids. And farther away still, In the outer reaches of the solar system, the sun is so distant the temperature is hundreds of degrees below zero. This is the realm of giant gas planets. Jupiter has no solid surface. But between the extremes of heat and cold, another planet was forming. One like Goldilocks' porridge that was neither too hot nor too cold. Planet Earth. "4 billion years ago, it was still growing as a rain of massive rocks, meteors, crashed into it, adding to its bulk. The newly formed Earth was a desolate, alien place, a dead lump of rock. Just dust and gas and the cold of space. There was no atmosphere, no life, nothing. So how did it turn into the familiar place we live in now? It was a slow transformation across such an immense period of time. It's beyond our imagination. But the answer lies beneath our feet, in the very rocks that make up the Earth itself. Some of these rocks, like granite, are radioactive. And as they decay, radioactive rocks produce small amounts of heat. It's such a tiny amount of heat that if we tried to boil a kettle by heating it with a cubic inch of granite, it would take about 4 million years. But then there was a lot of rock and a lot of time. The Earth was very patient. The heat from radioactive rocks gradually built up inside the Earth where it couldn't escape. Eventually, it did more than boil water. It melted the rocks themselves. Planet Earth had woken from her sleep. The Earth was now so hot, it was a raging furnace. The whole planet may even have melted into a vast ocean of liquid rock. Now the molten rock could flow. The lighter materials floated to the top, and the heavier materials sank. The Earth was rearranging itself into layers, like an onion, of different types of rock at different depths. It wasn't only radioactivity that melted the rock. The Earth was also heated by collisions as meteors still rained down from space. But eventually, as the radioactive materials decayed, the surface of the Earth began to cool to form a crust. As it did, it crystallized into a dazzling variety of rocks and minerals. Tourmaline, muscovite, gypsum, galena. Different materials came together, making different kinds of rock. The Earth's surface, its crust, became cold and solid, but deep inside, the planet was still hot and molten. One of the heavy materials to sink to the center of the Earth was iron. The pressure at the very center is so great, it creates a solid core. But around that, molten iron circulates in massive currents, a slow movement that turns the whole Earth into a huge magnet. In a compass, a magnetized piece of metal lines up with the Earth's magnetic field to point toward north. And for centuries, travelers have found their way around the globe, guided by the Earth's magnetic field. Even today, we still depend on the magnetic field generated by those slow-moving currents of molten iron thousands of miles below the surface. In the most sophisticated aircraft, a magnetic compass provides a backup to modern navigation systems. Because the Earth's crust is made up of different types of rocks, the magnetic field varies slightly in different places, so the magnetic compass isn't always completely accurate. But some long-distance travelers rely on these variations in the magnetic field. Every year, barnacle geese make the long journey from their nesting grounds in Greenland all the way to their wintering grounds in Scotland. They use a mental picture of magnetic variations as a map. They navigate so accurately that they can find one tiny island, Isla, off the west coast of Scotland, after a continuous flight of over 1,500 miles. All the barnacle geese from Greenland spend the winter here. The Earth's magnetic field does more than guide us on our journeys. It shields us from the solar wind. As our sun burns, huge solar flares, hundreds of times the size of the Earth, eject streams of charged particles that streak toward the Earth at the speed of light. When these particles reach the Earth, most are trapped by the magnetic field. Those that aren't are deflected to the North and South poles. As these particles collide with the upper atmosphere, they create the light shows we know as the Northern Lights, the Aurora Borealis. And the different gases in the atmosphere produce different colored lights. For people all around the Arctic, the northern lights were magical. They were powerful spirit beings reaching down to touch the earth. The Earth and Moon are the same distance from the Sun, but the Moon is much colder. Its average temperature hovers around 0 degrees. So why is the Earth so much warmer? If we travel back in time to when the newly made Earth was forming a solid crust, we would find the surface cooling down, becoming as cold as the Moon. But the Earth is bigger than the Moon, big enough to stay hot deep inside, big enough to have volcanoes that belch out gases, carbon dioxide, water vapor, nitrogen. They began to cloak the Earth in a blanket against the cold of space. The Earth now had an atmosphere, but it was one that would kill us in one breath. Carbon dioxide and water vapor trapped the sun's heat at the surface, and so the Earth warmed up, getting hotter and hotter. It may have reached nearly 200 degrees, hot enough to cook most forms of life on Earth, though not a high temperature by galactic standards. Across the galaxy, temperatures vary over tens of thousands of degrees, but from the time the Earth gained its atmosphere until the present day, its temperature has stayed within a very, very narrow range, no more than a few hundred degrees. And within this range, something special happens, something vital to our very existence, yet something we take completely for granted. Water exists as liquid. Any hotter, it would vaporize. Any colder, it would freeze solid. There can't be many places in the universe that experience the miracle of rain. Yet we grumble about it, shelter from it. All we do is complain about it. Only a few of us really appreciate liquid water for the miracle it is. But even more of a miracle, where there is liquid water, there is life. Life in all its variety has colored the whole planet. It's water that makes our planet the special place it is. Because without it, life on Earth could not exist. Water is the main ingredient of every living creature. It makes up over 90% of our bodies. All the complex chemistry of life must happen in a solution of liquid water. And at the heart of all this variety is one molecule. DNA, the double helix that carries the blueprint for life. From bacteria to humans, this is the very stuff of life. A molecule that can make copies of itself, that can change and evolve. A molecule that can build a creature that can step back and ask questions about the origins of life, about the universe, about everything. The first living molecules appeared very quickly after liquid water began flowing over the face of the earth. That something so complex, so delicate, so precisely structured could appear at all seems like a miracle. But however it came into being, this molecule, life, changed the world forever. The first life on Earth was a form of primitive bacteria which flourished in the warm primeval mud. These first bacteria must have had to live in water that was close to boiling. And this is how life on Earth existed for billions of years. Just bacteria, growing, feeding, reproducing, nothing else. The descendants of those first life forms are still around today, but only in places that resemble the early Earth. Places like Yellowstone National Park, where hot water runs freely. Mats of bacteria, hardly different from those first life forms, live around the scalding springs in water too hot for anything else. They carpet the hot rocks with shades of yellow and red. Famous for its steam and geysers, Yellowstone is a window on the Earth's past. Even when the temperature plunges 20 degrees below zero, the hot water never fails. It provides an oasis of warmth in ice and snow, not just for ancient life forms, but for more familiar, more recent creatures. Bison, with their thick, insulating coats, can survive the bitterly cold winters of the high plains, but they come to these natural saunas to thaw out. Why is Yellowstone such a bizarre place? Where's the heat coming from? A plume of molten rock has risen close to the surface. In the distant past, it caused eruptions of such power it devastated huge areas. It might be quiet now, but there's no reason why it can't erupt again. The Earth is still a very active planet, still evolving, still changing. The Earth's crust is not one solid piece of rock. It's broken into huge separate plates. Like a global moving jigsaw, these plates are slowly drifting around the planet. They ride on top of the Earth's mantle, rock that creeps and flows like sticky toffee. And while continents collide, volcanoes are born. Where two plates meet, one plunges down underneath the other. The rock forced downwards is under such pressure it melts and forces its way back toward the surface. Underground chambers hold reservoirs of molten rock, magma. When enough pressure builds up, the magma bursts out as a volcano. Different types of molten rock produce different kinds of lava. As the most active volcanoes are in Hawaii, scientists call different types of lava by their native Hawaiian names. Sometimes it's slow and sticky and crumbly, called a'a. Another kind of lava is more runny. It flows more quickly. Folding over on itself like batter, it has a ropey texture. This lava is called by its native Hawaiian name, pahoehoe. If plates are colliding in some places, they must be pulling apart somewhere else. North America is parting company from Europe at about the same rate that fingernails grow, but the line of separation is hidden deep beneath the Atlantic waves. These two plates are pulling apart along a ridge of volcanic mountains that runs down the middle of the Atlantic Ocean under 3 miles of water. It takes equipment as sophisticated as the space shuttle to explore these depths. And in the crushing pressures of the deep sea, we find things we could never have imagined. Black smokers, water at temperatures reaching 600 degrees, erupts out of the rock carrying minerals from deep underground. Black smokers exist because there is molten rock just beneath the surface. Water, seeping into the rocks through cracks, is heated and erupts back into the sea, carrying minerals that color it black. That same lava will eventually create new seedbed when it wells up to fill gaps left by the separating plates. And even more startling, there is life down here. Colonies of shrimp live on bacteria similar to those first primeval life forms. And the bacteria get their energy from the minerals gushing up in the smokers. This is life, but not as we know it. These are among the very few creatures on the planet that don't ultimately rely on sunlight. The volcanic ridge in the Atlantic joins with similar ridges in the other oceans, creating the longest mountain chain in the world. In the Pacific Ocean, the black smokers support strange gardens of tube worms, over 3 feet long, again living off bacteria, this time inside the worms. The discovery of black smokers has raised a whole new set of questions. Some people even think that this was where life first appeared on Earth. Could these deep, pitch-dark volcanic vents be the source of everything that lives on the planet? As yet, no one knows for sure. In fact, we know less about these hidden depths of our world than we do about the surface of Mars. This great volcanic mountain chain is submerged under 3 miles of water. But in the Atlantic Ocean, there's one place where the ridge rears its head out of the sea. Iceland. Halfway between Europe and America, Iceland sits on the northern end of the ridge where the 2 plates are tearing themselves apart. "1,200 years ago, an Irish monk, St. Brendan the Navigator, arrived here after a dangerous journey across the Atlantic from Ireland. He could never have imagined such a place. He was convinced he had found the gates of hell. St. Brendan wasn't far wrong. The fires of the underworld are very close to the surface here. Iceland is the most volcanic place on Earth. The Icelandic sagas tell of how the world began, but they also speak of how it will end. Ragnarok, a time of fire and smoke, when the gods will return from whence they came, and the world will be no more. In 1973, the island of Heimaey, off Iceland's south coast, had a private glimpse of Ragnarok. A volcano erupted close to the town, raining showers of ash and molten rock on the houses, spraying lava hundreds of feet into the air. More than 360 homes were completely lost, burnt or buried under the volcanic ash. Another 400 were damaged. But there are advantages to living on the mid-Atlantic ridge. hot water, and plenty of it. Apart from providing year-round bathing, hot water pumped from underground heats greenhouses, homes, businesses. Heat from all the volcanic activity just below the surface means Iceland has energy to spare. Iceland may be a land of fire, but close to the Arctic, it's also a land of ice. This is the biggest ice cap in Europe, the Vatnajökull Glacier, a slab of ice almost 2,000 feet thick. And underneath this huge glacier, in October 1996, just as described in the great sagas, the worlds of fire and ice collided. A volcano erupted, melting the ice at the bottom of the glacier, creating a violent explosion of steam and ash. Melting a glacier produces a lot of water. But after the eruption, nothing happened. For weeks, life went on as usual. On the surface, everything seemed calm. Just the normal slow melting of the glacier. Then, on November 5th, 4 weeks later, the water found a way out, and the flood began. Almost a cubic mile of water had been trapped under the ice and was released in a matter of hours. The flood was devastating. "30-foot-high boulders were swept along by the torrential waters. This was Iceland's most destructive flood in more than 60 years. Roads were destroyed and buildings demolished. Yet surprisingly, there was no loss of life. The island's largest bridge was specifically designed to withstand floods, yet it was swept aside like a broken toy. The cost of the damage would be close to $12 million. And the population of Iceland is only 250,000 people. But after the chaos, when ice and fire had fought their battle, the flood subsided. Calm and life returned to the land. Arctic terns nest on the debris from the flood. Living in a land of such extremes, it's not surprising that ancient Icelanders, in their great sagas, saw the living world as being created between the worlds of ice and fire. And they were right. This is the reason why planet Earth is so special. It was created between the extremes of heat and cold. But our story isn't over yet. Life had still to play its most dramatic role. For billions of years, in fact, for most of the history of life on this planet, there was nothing but ancient bacteria. And then something new, something devastating that would change the face of the planet forever. A new form of life, a green form of life, began to use the energy of sunlight to make its food from carbon dioxide and water. No longer microscopic, they were made up from many different kinds of cells working together. Oxygen was poisonous to the ancient bacteria. They were forced to retreat to places where the gas couldn't reach them. This is the worst case of global pollution the Earth has ever known. As the new life forms spread, oxygen began to build up in the atmosphere, creating the air that we breathe today. And it did even more than that. Oxygen turned the sky blue. Life is adaptable. New conditions create new opportunities. Creatures arose that could make use of all this oxygen. These were entirely new kinds of creatures, complex creatures. No longer microscopic, they were made up from many different kinds of cells working together. "600 million years ago, there was an explosive burst of evolution. And within a short period of time, every major design evolved, every kind of body plan that has ever existed. Nothing radically new has appeared on Earth since that time. Eventually, life left the cradle of the oceans and invaded land. life had claimed the whole planet for its own. For all we know, planet Earth may be unique, the only place in the universe where life flourishes. Or it could be that wherever there is liquid water, there is life. Either way, this is the only world we know. With every passing generation, our comprehension grows. Yet, at the end of our journey, we arrive where we started, in a world more full of wonder than we can understand. Next time on Forces of the Wild. Wind and water, two forces conspire to create nature's most bountiful treasures one moment and destroy them the next.